And we were very lucky when we were afforded the opportunity to partner with Jie Qi, who is here with us today, around Chibitronics. Thanks to a couple of our team members within the foundation knowing of her work and all the wonderful things she'd been doing over at MIT. And a lesson was developed by Dr. Gaskins that's up on our SCOPES website. So we encourage all of you, if you haven't been on the SCOPES website, to go check it out, along with the rest of the lessons that are there. But today we wanted to delve in a little bit, not just only in the technology, but also into the people. For those of you who are familiar with our Fab Lab network, we talk a lot about our technology being something that's a platform for people to change their livelihoods and change their communities. And it's not just about the technology, but it truly is about the people and all of their dreams and endeavors. So we'll delve in a little bit to learn a little bit more about Jie Qi. And then she and Dr. Gaskins, Nettrice, Nettie B, will talk a little bit more about their particular project. But before they do that, I do want to share a little bit from their bios. So Jie Qi is the creative designer and co-founder of Chibitronics. Chibitronics got started a couple of years ago, and the whole idea was to combine art with engineering to empower creators of all backgrounds to make their own expressive and personally meaningful technologies. Her research explores the intersection of traditional papercraft, bookmaking and storytelling practices with contemporary digital technologies. She is also an affiliate of the Berkman Klein Center for Internet and Society at the Harvard University Law School, where she investigates open approaches to innovations and entrepreneurship. So thank you, Jie Qi, for being with us today. And then our very own Dr. Nettrice Gaskins has been doing phenomenal work in STEM education for many years now. She has a doctorate in digital media from Georgia Tech. She has also been working around the issues of STEM learning for underserved ethnic groups in public schools in the United States and all around the world. Dr. Gaskins also received funding from the National Science Foundation for advancing STEM through culturally situated art-based learning, and has been serving as our program manager at the FAB Foundation for SCOPES. So let's have a wonderful hour with these brilliant ladies during Women's History Month, talking all about STEM. Thank you.
Wanted to mute while Sonia was talking. Jie, we want to get started. I guess I had asked Jie to tell her personal story of how she came to be where she is now, and as a way to sort of talk a little bit about your process. I think that's important, your journey, and then to do some demonstrations. Feel free, go ahead, Jie.
Yeah, hi. So thank you for that lovely introduction, and thank you for having me here. This is really cool, really fun. So I guess my journey, my story is very, very winding and kind of not planned, but I'm excited to be where I am. So I guess starting all the way back from when I was in high school, my parents are both doctors, and so they wanted me to be a medical doctor. I guess the joke's on them because I have a doctorate, but it's like a different kind. Anyway, but when I was in high school, I was like, okay, I'm gonna be a doctor. I'm gonna, do all these things that my parents want me to do. And so I was like pre-med going into college. I studied biomedical engineering, and I worked in a tissue engineering lab doing cancer research. And it was like, important, and my parents were happy. But deep down, I like to make stuff. I love art. I love kind of doing hands-on creative things. And I realized that within the medical context, you also have to be creative, but not quite personally expressive in the same way you would be if you were an artist, right? And so halfway through undergrad, I had this big moment where I decided I'm not going to be a doctor, and then I switched my major to mechanical engineering because the mechanical engineering kids got access to the machine shop. So I was like, okay, cool. I'm like making the stuff again, and this is great. Around that time, junior year of undergrad, I learned about Aya Badir, who was an artist who does work with technology, and she created this awesome thing that was called Little Bits. Like, this is back in 2009, before Little Bits was a company, and I ended up connecting with her, and I became her like intern, like, you know, solder monkey. I was there basically doing whatever she wanted to do. And that's actually, even though I didn't really know electronics, I wanted to work with her so badly that I was like, I'll learn anything you want me to do. And so that's how I learned a little bit about circuits. That's how I learned to solder, by helping prototype Little Bits way back in the day. And then that actually, you know, kind of got me interested in, oh, maybe electronics is this interesting thing too. And Aya was from the media lab, and she knew a new professor, Leah Beakley, who had just started, and she told me to get connected with Leah. And so I contacted her, and I ended up doing a summer internship at Leah's new group called Hilo Tech. And Hilo Tech is a research group that combines craft, textiles, paper, sculpture, anything with technology, like electronics especially. And that's where that summer would kind of like change the course of my life. I went there, and I had always loved paper craft, and I loved kind of engineering because it allows you to build things that are kind of more complex and do things that you might not otherwise be able to accomplish. But in working with Leah, I learned that I could put my like love of paper craft and my love of like engineering problem solving together to make wonderful things. And so it was that summer that I made this pop-up book that had sensors and kind of interactive lights and elements to it. And so I think I'm gonna attempt a screen share to show you what this is. Called it Electronic Poppables. It was a very quick title. I probably should have thought about it longer, but you know, it is what it is. So where is it? Here. Okay. How do I, now that I've clicked on it, how do I share? Ah, here. Hello, do you see my screen? Okay, awesome. So basically this is a page from the book. I'm gonna play this video for you all. This is with Leah and my collaborator, Shen. And so here's the first page. It's a pink page where, oh, sorry for the ads, where you pull on the tabs and they're actually switches. And they blink on and off when you pull the tabs because you're actually closing electrical switches. And then the next page is potentiometers, which I made using conductive graphite paint. So instead of turning on and off, the lights can slowly, gently fade in and out. And this is an underwater scene. So when I swing the tabs, you see things move, but also the lights change. And there's a battery in the corner that makes this whole thing turn on. Can you guys hear me okay? Is it okay? Okay, cool, awesome. And then the next page is my first pop-up electronics page. It has an Arduino in the middle, and there's two like skin sensors. When you touch the stars, it causes the lights to shine a pattern and play Twinkle Twinkle Little Star. And all those gray lines are also conductive paint. Next one is pressure sensor of planets. So you can see the sun glows when you press on Pluto and other things. So things fading in and out when you press on them. Or yeah, the moon goes away when you press on the Earth. And the next page is the bend sensor. So when you lift up the sailboat, it turns on the lights in the skyline. I made it of New York City because there's still a very special place in my heart for New York, since that's where I studied and where I went in middle school. And And the last page is capacitive sensors in nitinol, which is shape memory metal. When you touch the leaves, they sense your finger and then they like slowly close, very slowly, because I was working with a dead battery, but you get the idea. So I'll let that kind of do its thing. You can kind of see it move a little bit. Okay, cool. So, or maybe one more. Okay, yeah. So I'll pause that. And the thing that I kind of learned from this project is two things, actually. First, when Leah first assigned me to make some sensors out of paper, I was like, okay. And I started making sensors that are squares and circles because that's what buttons look like to me. You know, they're all rectangles and circles. But then as I started to make more, I was like, well, why do I have to make them squares and circles? I can make them anything because it's just paper. I can cut it to any shape. And so I started making these scenes, and that's when the sensors became so much more interesting because they weren't this abstract thing anymore. They were an actual, like a bumblebee or a building or something. It became more meaningful. And so, you know, the electronics that I'm learning became more interesting as I was able to add like a character or some meaning, personal meaning to it. And meanwhile, my papercraft, which I loved all along, came to life because it was doing stuff. It was glowing, it was sensing, it was really awesome. And so when these two cool things that I already loved came together, it became an even cooler thing that I loved even more. And so that kind of like, I fell in love with this medium, and I've kind of, you know, I'm like, well, I'm probably not the only one who'd enjoy this. I've been sharing kind of this approach ever since with everyone, including you all, like today. And the other thing that I learned is, so this is the first time I programmed like a circuit. This is the first time I programmed my own project. I actually took programming class, AP Computer Science, in high school. I tried. I took it as an online course because it was available in the state of Florida. And it was this horrible experience because I'd never programmed before. There was probably 100 students in the class. Some of them had been programming since they could probably hold a spoon. And so I keep getting news of students winning like statewide competitions and stuff. And meanwhile, I'm like, I can't get this calendar assignment to work. And so I ended up like feeling really badly and thinking like, I'm obviously not a programmer because I can't get this. And, you know, I think it's a horrible idea to try to learn programming by yourself online, but I didn't know that at the time. So I ended up having to drop the class, and I was just like, never again. But when I picked up an Arduino and made my buildings glow, I was like, holy crap, this is why people like programming. So it made me think about it totally differently. And after this internship, which I did in the junior year of my undergrad, I went back, and during senior year, I like took programming classes, and I did well in them, and I felt so good. And now I'm like a really, you know, a huge fan of using code to control and make things happen in our world. So this project kind of like, this was my journey, this like my big, you know, thing that completely changed how I thought about my work, about programming, about what's possible. And it's kind of set the path for the rest of the things that I've done, including what I do today. So I'm gonna stop sharing. I just want to share this lovely way of making that made me feel so, I guess, empowered with everyone. And that's why I've been working so much on teaching workshops and making tools like circuit stickers, like Chibitronics, and creating books to share this way of making, so that anyone can also enjoy making their own circuits and telling their own stories and writing their own code and programming their own projects. So that's kind of how this all began. The journey is more winding, but maybe I'll take a pause there. Yeah, thanks. So yeah, should I share a little bit about what Chibitronics is, or?
Absolutely.
Yeah. Okay, so Chibitronics. This was my this ended up being my PhD project, but it's around this idea of making circuits using stickers that are actually electronic. So I have an example here from my book. Oh shoot, this one is in Japanese. I happen to be in Japan right now. So it says circuit sticker sketchbook, but it's in Japanese. But it's okay, the circuit's the same. But anyway, So you could actually download this whole book from our website. I'll send you a link later. But the idea is here, let's see, here's this little triangle. That's actually a sticker that's made out of a circuit board, a flexible circuit board. So these are the same circuit boards that you have in like your laptop that connects your screen to your keyboard. But we use them to make stickers instead. And on top of this, it's hard to see, but there's a little LED. And on the back of the sticker is conductive adhesive. So the glue will conduct electricity so that when you stick it down onto this copper tape, you actually make an electrical connection. So these lines are tape made out of copper metal. Copper is metal, so it's conductive, and so it'll complete your circuit. The only thing that's missing is this guy, which is, it's a battery, just a thin coin battery. And I'm gonna put it on here. I have a magnet here, so it's not magic. It's not like sticking to the paper. It's just being held in place by magnets. And then when we close this, we complete the circuit, and you see that light turns on. So maybe you can see that, you know, turning on and off when I close the circuit. So that's one way to build a circuit on paper. One thing that I think is really important, and that I kind of shared, is so the circuit's really cool, awesome, you know, you got that part, but I think it's also important to tell a story with your circuit. So when you turn the page, it's actually a light bulb that turns on, and in this scene, I turned it into like a kitty playing with some yarn. So, you know, it's so here in Japanese, it's asking, what do you see? What do you illuminate when the light bulb turns on? And it's like, a cat. Because I like cute animals, so I made a cat. So, you know, that's your first circuit, but then you can do more complex things, like you can draw with your circuit. So here I drew a cat out of my circuit. You can add this, and it's like head glows. It's like a Zen kitty. So all these lines I made using copper tape. After that, we've got a parallel circuit. So, oh yeah, each chapter also explains, like, you know, this is the kind of circuit we're making. Here's your supplies, and then here's like a little page where you can actually build your circuit. This is a parallel circuit, which means we can turn on, whoops, stay battery, there we go, which means we can turn on multiple lights in parallel using one battery. And the scene is of an owl at night with the stars. So here we go. We've got an owl and the stars glowing. And so the scene, the book kind of continues. I'll show you one more because, you know, I think these are pretty fun. This book is kawaii themed, so like all cute things. So this one is kind of fun. Here's our battery. And then here is this black material. It's called Velostat. It's actually used, it's like there's carbon particles which are conductive inside this rubbery material. And when you, it's used in like packaging for a lot of electronics to prevent static. But when you press on it, it becomes more conductive. And so the the harder you press, the more current can go through and the brighter your light gets. So basically you can use it to make pressure sensors. So the harder I press, the brighter the light is. And then if I slowly let go, it'll get dimmer. So it's like a very gradual, pretty, you know, effect. And the story here, trying to tell stories. I like stories, so I want to tell you guys stories. The story here is that this is not Fuji, and when you give him or her some love, I guess her heart starts to glow. Somebody said it looked like lava, so perhaps she's erupting when you press on its heart. And here's the clouds when you, let's see if I can get it going. Oh, oops, there we go, much better. So here, I don't know if you can see when I slide my finger around the stars twinkle. So it's like if you rub the cloud's belly, it'll like burp out some stars. So, you know, there's all sorts of things that you can do with your circuit, like telling stories about mountains and clouds and cats and owls. So that's just an example of some things you can do. And the whole point here is that we're combining the problem solving, right? You have to figure out how to put your circuit together the right way for things to turn on, but there's also, you flip the page and it's a blank empty canvas for you to do whatever you want. And so you get to practice, you know, using your imagination, choosing things that you like. When there is no right answer, nobody's going to tell you what to draw. You have to decide that for yourself. And so, you know, I think it's important to kind of have both of those, the freedom, open-ended bit for you to express yourself, where you know, there's no right or wrong answer, and you kind of have to build some of that creative confidence to create something, as well as the kind of guided, more problem-solving activity where it's like, well, you have to figure out, you know, is all your connections in the right way in order for the circuit to turn on and behave the way you want it to. So, you know, trying to put that together. And I found that, you know, some learners like to start with the drawing, some learners like to start with the circuit. And so, you know, you can enter this in different ways depending on what you like. So that's that. I'll give a quick demo of the other thing because I don't want to take too long. Actually, maybe you'll be sharing more on the programming side, right? Okay, so I'll just say very quickly, there's this other thing that we're doing that involves programming. Here's like a book that similarly has characters in it that teach you programming concepts. This is our friend Fern the Frog. She's frustrated because she's trying to learn electronics and it's really hard. But then, you know, her friend Sammy comes along and is like, let's do this together. And then Fern learns with her friends. And then the rest of the book is different programming concepts that Fern learns along with all of her buddies. I won't go too far because I think we'll be hearing more about that soon. So yeah, that's a quick demo of Chibitronics. Oh, and quickly, Chibitronics means Chibi is like small and cute, miniature, and Tronics is like electronics. So I wanted to make electronics friendly and cute and not scary. So that's that.
Jie, could you also talk about the Chibi Chip?
Ah, yes. So very important. How does all this programming stuff work? It uses this little thing, or this thing. Okay, here we go. This is a Chibi Chip, and basically what it is, it's like a programmable microcontroller, or rather, it is a microcontroller, a programmable microcontroller like an Arduino or a microbit. Maybe some of you have played with that before. And I'll just put this here. It needs power, so I'm going to plug into my computer for now. So you can kind of see here, there's like lights turning on and off that are on top of these pads. So this is actually the program that's running on the chip right now. So you can see your code doing what it's supposed to do, and then you can use it to control your circuit. Let's see if I can find a page. Here. All right, I'm going to try my best to do this. Maybe I should clip it first. So what you can do is you can clip the chip to your circuit. Here you go. Couldn't do that at the same time. So when you clip it onto your paper circuit, whatever is happening on the chip also happens in your circuit. So you can use it to program your circuit to you know, sense things or shine patterns. So it's no longer, the lights are no longer just on or off. You can now control them using the chip, which is basically like a brain. You can tell it directions, and then it'll do what you tell it to do, which is what the code is, instructions. So that's the Chibi Chip, and we'll be hearing more about this and how you can apply it in a learning setting shortly. Thanks.
Thank you.
Mm-hmm.
So I think what's interesting, I actually taught AP Computer Science, but the new version, Computer Science Principles, and I taught it not online, it was face-to-face.
That's much better.
And I think as it relates to your presentation, all of the high school students were art majors. So they were all art students who were taking AP Computer Science in like a fab lab makerspace place. So they were using, we started out with the circuit stickers, and we started out with paper circuits as a way, as a scaffolding to using Arduino and some other things. We also used the Chibi Chip in summer camp with middle school students, so they were able to do some cool stuff, including which inspired the lesson plan I'm going to bring up. Let me share my screen. Do that now. So on the SCOPES website, there's a lesson specifically about it's combining two types of coding environments, and it's also to produce this electronic card. So one of the things I wanted to do for Hour of Code, which is the Computer Science Education Week in December, was create a lesson that really had computation at the forefront and physical computing. So it's using Tinkercad's new program code blocks, as well as using the Chibi Chip and it's the Microsoft programming environment for Love to Code. So this is the lesson plan. It's basically you create a postcard, but the postcard has different elements, and it's also using art. It's using printmaking, and I wanted to bring all those things together. So you begin by sort of playing around with, and this is a computer science term, variables. And then you can use code blocks to play around with variables, learn how to make a design. What's really cool is you can make it 3D almost instantaneously. So you're not working in a 2D environment like you do with Scratch and some other programs that are visual programming languages. You're working with 3-dimensional objects from the very beginning, and you're coding and creating design that way. After that, you have, you can go in different directions. You can 3D print your object, your graphic, or you can make a 2-dimensional and laser cut it or laser etch it into wood. And then in this case, it was used as the background for a postcard. So it was laser etched into wood, and then through printmaking, relief block printing, we made a postcard from it. So after the postcard was made, on the inside of the card, and I had a sticker, but the sticker I think wasn't working, so I used the LED, a regular LED on top with the Chibi Chip, and it blinks and it comes through. In order for that to happen, you have to code the Chibi Chip. So this is the Microsoft MakeCode programming editor. It's still block-based, or it's still visual programming language like code blocks. So you're still kind of using the same terms. There's variables, there's other types of things that students need to know or in order to produce it. But what I like about this MakeCode is that you have a block-based editor and you have a JavaScript editor. So if you wanted something to look more like Arduino, you could switch over and become more familiar on how to do that, and it'd be a good way to begin doing code so that you would be able to use Arduino's in development environment. And so you also are able to use the audio port on your laptop, or you can even use your mobile device, your phone, to code your Chibi Chip. So that's another benefit to using the Chibi Chip in that environment. And then this is the final, which is the card that was made starting with code blocks and then moving into the Chibi Chip. So this is a lesson plan just to bring programming or computation to the forefront. And it was a way to also bring in some of our Fab ICANN statements as relates to that, as well as some other US-based learning standards to learn how to do this project. So this is kind of taking some of the things that Jie Qi was doing and moving it into a lesson plan. All right.
Cool.
So our next sort of on the agenda is to do some Q&A. So I'm going to check chat, and we also have a couple other people in chat as well to see if anyone has questions. So if you do have questions, you can, I'm going to actually make it available so that we can see who you are and you can speak for this part of the webinar. And feel free to do that. It's kind of one by one, but once you're a panelist, you're able to ask questions. There's an audio mic to click on your lower left screen if you need to hear or need to speak. It may take a couple of seconds for you to appear. Does anyone have questions for Jie?
I have a question, if no one else has one. You talked a little bit about your journey at the beginning.
Mm-hmm.
Can you speak to the value of having the female mentors and role models that you have?
Yes, that's such a good question. Yeah, I think what made it all possible was exactly these amazing people that I was super lucky to work with early on, like Aya, Leah, and I have another mentor, Sally, who's been, you know, a part of my life and amazing. And yeah, it was before I met Aya and knew about her work, I didn't know it was possible to do art as a engineer or scientist. I just thought they were all split, and like meeting her, seeing her stuff was like, this is possible, like holy crap. And same with Leah. And but beyond just kind of the role model, which they totally were and still are, they were so kind to take me, who's like this random undergrad who really didn't know that much, and trusted me and like supported me as I was learning. So like, for example, when I first started working with Aya, she gave me an Arduino and told me to like make something with a DC motor. I didn't tell her that I had never touched an Arduino before and didn't know anything about motors. And so immediately I plugged the motor in directly and killed her Arduino, which she needed to teach the class next week. But she was, you know, she was okay with it. You know, and yeah, for the first month, I basically just destroyed everything. And then after a month or so, I started not destroying things. And after another month, I started actually making things work. But she was supportive and patient with me during that period, and I was able to learn and feel, you know, okay about myself, and realize that, you know, destroying things is sometimes part of the learning process, so it's okay. And so having mentors like Aya, and then, you know, Leah, who kind of guided me toward my own experiments and creating these things, and who, you know, she later became my advisor as a graduate student, was super duper important, because, you know, as I was learning, I'm gonna lose confidence. I'm gonna like mess up everything. And they were, you know, not only inspirational in their amazing work, they were also extremely supportive to help me like kind of grow and figure things out. And of course, you know, as I continue to, you know, learn and work, they, you know, they also give me suggestions. They also connect me to resources. It's like all these amazing things that I just would not have been remotely capable of learning all these things and doing all these things that I have done if it wasn't for people like Aya and Leah in my life supporting me. And I hope to support them too somehow, other than giving thanks, lots and lots of thanks. Yeah, so that was huge. And now, you know, I feel super blessed to have them and their support and people like them in my life. And I try my best to, you know, share with others. So, you know, if there's anything I can do to help, let me know, because I feel super grateful. I wouldn't have possibly been here without the help from tons of other amazing people. Yeah.
Could I ask a question, Jie? You were at the Media Lab there. I have a couple of questions, but okay. One is, you know, Aya and Leah were obviously inspiration, and both of them are very much about equity, right? About equity to the tools and the knowledge of technology, right? And certainly in the Fab Lab network, we really, we think about that and strive, you know, strive towards equity in many different ways. And, you know, one of the ways is the way that Nettrice sort of designs and thinks around culturally relevant, you know, culturally relevant projects and applications, right? But what drives you? I mean, what I see and what I experience even in the Fab network, but what I see through you all is it's a lens towards ease of use and you know, sort of an easy on-ramp and accessibility, right? But is there something that you do beyond that that you that is part of your strategy for equity? I know it's not a nice question, but I mean it's a hard question.
It's a great question.
About it a lot, and I'd love to hear what you think.
Yeah, no, totally, and that is definitely a big part of it, because, you know, I'm a woman who's doing engineering. I'm an immigrant. I was born in China. I moved to the US when I was 5, and I couldn't speak English when I was in kindergarten. Like I you know, I've had my own struggles. I went to some like severely underfunded schools in Brooklyn, New York when I was in middle school. So I know what it looks like to be in a place where, you know, it's not a really supportive environment for learning, I'll just say. But I'm also so lucky to have been also in places of extreme privilege. The Media Lab is one of them. And so I can see the inequity that exists. And so personally, I'm very, very motivated by making, for me, like technology is also this like clubhouse. It's this, I don't know how to say it, but it's like there's a power dynamic there. If you know engineering, if you know all this stuff, somehow you're in a better position. It's true. And I personally think that there are people within this community that want to keep it exclusive, you know? And so my goal is to try to disrupt that. How do we make technology, programming, engineering, whatever, hardware, not just something that engineers in a big company will sell to you? It's something that you can create yourself. And that's why, you know, that's why I'm doing a lot of this. I want to make these materials friendly. And I guess the approach is using materials that people already understand, like paper and tape and stickers, to deliver these new concepts, like you say, the on-ramp. The other thing that I've been really pleasantly surprised that I think it's kind of working is, you know, engineering is typically a male-dominated field, I would say. I think maybe many people would say. And, you know, I wanted to make this fun for everyone. And even though kind of it started as a more kind of a maker, perhaps educational STEM learning focused tool, the stickers, paper circuits, has also now been used by the craft community. So these are people who like to make cards, you know, these beautiful paper creations. And the people that make these are typically adult women. And so what we're starting to see are adult crafters who are typically female, you know, building these awesome, beautiful, super gorgeous electronic paper crafts. And what's cool there is like a lot of them are moms or grandmothers, and they teach their kids. And, you know, so like all this learning is, you know, making it not just in the classroom, but also outside at home in the family. And this is really great a story that I remind myself on, you know, when I need it to be cheered up, which is we got this email a few years ago from a grandmother who had a question about how to make a light up card for her grandson's birthday. So, you know, we answered her question. You do it like this, da, da, da. And then like a few weeks later, she emailed back and was like, oh, thank you for your help. I got the card to work. P.S. Instead of making a card for my grandson, I hosted a birthday party for him and his friends where they all made their own cards and I taught them how. And I'm just like, this is so cool. Grandma is teaching grandson and his friends how to build electronics for his birthday. And that's just happening by itself. It wasn't like, you know, it was not a homework assignment. This was something that they just wanted to do for fun. And so this is starting to naturally happen. And that just warms my heart because that kind of confounds many, you know, typical, I don't know, expectations about who's building electronics and what kind of person and, you know, and so I think that my hope is that one day everybody can feel comfortable engineering. Not everybody should be an engineer, you know, but everybody should feel comfortable with these skills. And so that it's like ordinary, like, you know, most people know how to, you know, navigate the roads. Maybe one day most people will know how to, you know, program their own devices. That would be nice, like a totally ordinary thing. That would be a nice goal. We'll just see circuits next to the crayons. That's my goal.
Thank you very much for that.
Mm-hmm.
Anyone else?
Maybe I'll jump in very quickly. I mentioned I was going to tell some links, so I'll just put that in the chat window now. So on the Chibitronics website, we have a whole bunch of tutorials that might be helpful. So there's like, this page has videos of every chapter in this little book that you can just download the template. You don't have to get the physical book and then print it out yourself. And also there's a link to the sketchbook here, which you can have the 3 different languages if you want. So you can download the whole book yourself. That's the second link. And then the last thing is we have a bunch of templates as well on our website for different kinds of circuits. And these work with stickers, but really you could also just bend an LED and stick it on top, and that would work too, as long as you have the direction right. So these are just some, you know, helpful printable resources for you all to use. That's it.
We just a side note, the tabby boot lesson plan, the boot we made for Black Panther, and the heel is the velostat, so it's a pressure sensor, so intended to light up the LEDs on the ankle part of the shoe.
Cool.
So it has that black material sewn into the boot, into the heel of the boot.
That's awesome. Yeah, that stuff is so nice. It's also super cheap because it's used in packaging, which I'm a fan of.
So, Jie, I assume that these are all, I don't know that it's open source, but it's certainly open for use, right?
Yeah. Everything we make is open source and under Creative Commons. So the book and all of these templates and things, those are all under Creative Commons, just so you can feel free to print it, remix it. We just asked, if you do share something, please also make it under Creative Commons and you know, just link back to us or something, so that we can continue to all share and grow our resources. But yeah, so we're an open source hardware company. All of our code, the design files like this, they're all online, I think on GitHub. So you can also create your own if you like. Yeah, the goal here for us, where I characterize Chibi as an accidental company, because we started as a research project and our goal was to get it out as far as possible. And being a business ended up being the best tool for that. But at least my hope is to spread this as, you know, widely as possible. And so we want to not have any barriers. And so everything's open as much as we can afford to make them. Yeah. And also, you know, I'm a huge open source nut. I think that by being open, it's also much easier to collaborate with people. So that's been really great. And we have tons of awesome collaborators, like maybe you all.
Thank you. That's
all. Yeah. Cool. I see the link for the Black Panther collection project just popped up on the chat. Cool. Yeah.
What are you doing in Japan?
Good question. So I am based in Tokyo now. I'm what is called a project assistant professor in this lab called the Kawahara Lab. And my focus is on printed and flexible circuits for books. So I want to figure out, how do we integrate electronics and sensing into regular physical books so that we can make them interactive. And also think about ways that we might be able to publish these so that they're not just sitting in a laboratory, but that they can start showing up on bookshelves. Because I am a lover, as you probably have guessed, of paper and physical books. And I want to bring kind of the wonderful magic of digital technologies to these lovable, cozy books. That, yeah, so that's my research here. And also while I'm here, being a paper lover in Japan is kind of like being in a giant candy store. So I'm learning a lot about different kinds of paper, because it's a very strong part of the culture here, which is pretty cool. So there's some really awesome stores.
Let me ask you, I'm sorry, go ahead.
Someone in the chat has asked me to pull up the tabby boot, the one I mentioned that had the velostat. There's a link to it in chat, but someone asked in the chat to show it. So I just want to just show where it is, and for like a minute, just pull it up. So you should see this part of the lesson, which is step 5, after you've laser cut felt. This pressure sensor with the velostat was created with the Flora to be a pressure sensor. So it's the same material that Jie showed in her circuit stickers. So that's there as part of the e-textile component of the boot. And it's on the lesson plan's Black Panther collection. Okay, continue, Sherry.
I just wanted to ask you, I feel like even the book, the pop-up book especially, is a really interesting kind of design and engineering project in and of itself. Can you talk a little bit about how you did, how did you learn how to do pop-up right? And all of that, because it's a very cool, it's a very cool application, as it were, of geometries and mechanics and, and art and paper.
Yeah, thank you. Yeah, so pop-ups are really fun in that that you can just make them out of like normal papers, and there's so many amazing books. There's one book that I like that was like my Bible when I was making that project, called The Elements of Pop-Up. I'll just Elements of Pop-Up by Carter and Diaz, I believe. These are two different last names, so just if you search that, it will show up. But basically, it's a big pop-up book where each page is just different examples of pop-up mechanisms, and so you can open the book and just play with this mechanism as like inspiration, as well as see how it works. And then it also shows you, like, it gives you a template to like print and cut out to make your own version of that pop-up. So that is kind of where I like learned all these techniques just by looking at it, and it's so great. And you can do them just with some paper and some glue and some scissors, basically. So that's how I learned a lot of the pop-up mechanism, just looking at existing books. And the process for, I guess, creating that, I started out, like, basically Leah told me, Gee, I want you to make sensors out of paper. And that was it. And so when I started out, I actually made some like just buttons by themselves that were, like rectangles and squares and circles, because that's what I thought sensors look like. And then somewhere along the line, I just cut a little flower out of pink paper and then I put that on top of the button. I was like, way better. And then I was like, okay, well, if I need to showcase these, maybe like I at first I was like, I'm gonna make Alice in Wonderland because this is such a cool story out of like lights and stuff. And then I was like, this is too hard. I can't figure out the mechanisms and fit the stories too much. And so then that's when I was like, okay, back to the flowers. And then I realized as a process, like I needed some structure. Like if I'm staring at a totally blank thing, I'll just kind of freeze up and don't know what to do. And so I ended up thinking like, okay, well, here's some switches. This is a flower, so maybe it'll just be pink. Let's keep our colors limited. And so I made the first page of different kinds of flowers, and those were all different kinds of switches. And I was like, okay, well, then that makes sense. Maybe each page is a different type of sensor. And then it kind of went on from there. But I had to create a structure for myself, because in the beginning I was just kind of all over the place. And then once I made 2 pages, I was like, okay, there's a color, there's a theme, I got this. And then it was more like, okay, what are other sensors that I want to share? What are some other scenes? And then that's kind of how it came from there. And just I wanted to learn how to do pop-ups, and I wanted to, well, at the time, this was my first time making paper circuits and like playing with conductive craft materials. I wanted to try as many different materials as possible, like paints and fabrics. So I used every single material that like was in the room that Leah had compiled. And so I got to learn about the different materials. If I were to do it again today, I realized that with every new material, you make it that much more complex. So I would probably like have simplified my palette if I had known, but I was also learning in the process of making that book. So there are a lot of decisions that really don't make any sense in it, but it was a learning experience. And so that was, it worked for me. And to be honest, when I was making it, it was just like, oh, this is for fun. I'm like making this cool thing that I've never seen before. This is great. I didn't realize it was gonna like change the course of my life, but basically it did. It's funny how that works sometimes. You don't realize how important things are until like 5 years later. So yeah, that was that. I had no idea. I was just playing and it turned out really nice, basically. Yeah. Now, surprisingly, it's hard to just play sometimes. Yeah.
Oh, that's hard. That's sad to hear. I'm really sad to hear that.
Well, I'm trying. I mean, part of my journey coming to Tokyo is to kind of like start in kind of a fresh context, and so that I can be a little bit more experimental again. Yeah.
So I have a question, but I'd like to hesitate since we only have 5 minutes left in case there's someone here who hasn't had a chance to ask a question that had one. Speak now or forever hold your peace. Okay, well, I'll go. So this whole notion of equity and access is really important in your work for lots of reasons. I think you've shown it in the technology, but I'm also aware that you have another project that really speaks to it as it relates to policy and law. So would you mind giving people a little snippet of Patent Pandas and what that's all about?
Yeah, thank you for,
Sorry.
what?
I said it backwards.
Oh, no, you totally got it right. Patent Pandas. In fact, I will put that in the chat link, patentpandas.org. Yep, okay. Thank you for asking. This is actually one of my newer projects around, like you said, law and making it accessible. So relating to that pop-up book that we were just talking about, I actually ran into some issues where I went to a job interview. It was a surprise job interview. It was just a visit to this group at Google who was interested in making interactive books. And I shared with them my work and they offered me a job, but I couldn't take it because I was still in my PhD program. I didn't want to drop out. And so, you know, then I left. And then a few years later, I found out that they were trying to patent exactly the stuff that I had shared with them. And yeah, it's a little crazy. And so, and they, at the same time, within about a month of finding out about that one, I found out that one of our crowdfunding campaign backers for LED stickers, the thing that I just showed you, they successfully patented the LED sticker, which is insane because when they applied for their provisional patent, which is like the earliest thing, they already had our kit with them. We already shipped the kit. And so when I found out about these two, I was like, holy crap, the patents are really weird and kind of maybe a little broken. Luckily, I was at MIT at the time and I had all this amazing support from the community there. My co-founder, Bunny, also had some experience within law. And so basically we were able to navigate this. Again, I was very blessed with many mentors and resources that I think are not usually available to someone in my position. And so because of all of this experience, and I knew that I turned out okay, like the situation turned out okay for me, but I knew that many other makers out there probably don't have access to these resources. And the biggest thing was, you know, I was panicking, but because I was able to talk to these lawyers and other people, they were like, don't worry, this is what you should do. This is not as bad as it looks. This is as bad as it looks. You should do this. You know, all of these things, we were able to navigate it. So I wanted to share that, what I learned out with everyone. So I made this website called Patent Pandas. And the whole idea is, there are a learning, actually I could probably just share my screen. Let me do that. Patentpandas.org. And then, sorry, I have like 2 minutes. Maybe I won't share my screen. You should just check it out yourself. But basically there's stories like mine of what it was like to go through, what I did, you know, what was the advice, how it felt, you know, it felt really scary, but then I did this and it turned out okay. And so there's stories of like true things that happen to people like me. There's these resources that are like, you know, different posts. What is prior art? What's a patent? You know, all of these things that are told through these panda comics. So my sister likes to draw anime, and so she helped illustrate all these pandas. And so through these different panda characters, you learn about what, you know, patent law basically. And finally, there's a page that links to free legal resources. So these are clinics at law schools or volunteer branches in law firms where they will talk to you for free to, you know, help you at least figure out, you know, what is the situation. And so the biggest thing is law is super not intuitive, and you kind of need a guide, and the lawyers, your guide. I used to be terrified of lawyers. I just thought that they made things complicated, but I realized it's like, they're like doctors. It sucks to have to go to the doctor, but you should go to one when you're in trouble. Same thing with a lawyer. So that was kind of the experience, and that's what Patent Pandas is. So I hope you check it out. Everything's under Creative Commons and there as well, so you can feel free to share, print, whatever. And then I gave a talk about this and about my experiences that's on the website, so you can check it out. That's Patent Pandas. Thank you.
Wow, thank you. That was amazing. We'll have to have a whole nother webinar with you just dedicated to
Oh, and a quick thing, everything on that website has been reviewed by lawyers. So people from the Harvard Law, Cyber Clinic, other clinics. So everything is like legally very sound. So you can trust it, and we're not trying to sell you anything. So that's the other thing. Thank you.